بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 3.10 is talking about the hyperbolic functions. So we aim in this section to introduce hyperbolic functions and their identities and their derivatives. Also, we need to introduce inverse hyperbolic functions and their derivatives. First of all, let us know what is the building blocks for hyperbolic function. For the hyperbolic function, the building blocks is the exponential function, which is exponential of x and exponential of minus x. So, let us start by the definition 3.10.1, the hyperbolic sine and cosine. For any real number x, the hyperbolic sine of x is given by hyperbolic sine x, or you can say sinh of x, is equal exponential of x minus exponential of minus x divided by 2. So the hyperbolic sine is given by exponential of x minus exponential of minus x divided by 2. And similarly, the hyperbolic cosine of x is given by hyperbolic cosine x, or you can say cosh x. It is equal exponential of x plus exponential of minus x divided by 2. So the difference between hyperbolic sine and hyperbolic cosine is just this sign. For hyperbolic sine, there is an addition between the exponential function, whereas in hyperbolic cosine there is an addition between the exponential function. Here we have a graph for y is equal hyperbolic cosine and also another graph for y is equal hyperbolic sine of x. So let us first see this graph for y is equal hyperbolic cosine x. So if you see here, this one is half exponential of x and this one also half exponential of minus x. The domain of hyperbolic cosine is any number you can substitute for the x-axis. So here the domain is from minus infinity to infinity, whereas the range is starting from 1 to plus infinity. So the domain of hyperbolic cosine from minus infinity to infinity and the range from 1 to infinity. For y is equal hyperbolic sine x, here we have minus half exponential of minus x and here we have half exponential of x. The domain of hyperbolic sine, you can substitute any value of x, so that means the domain will be from minus infinity to infinity. Also, the value of the y-axis, it can be negative number, it can be 0, it can be positive. So the domain and the range for the hyperbolic sine will be from minus infinity to infinity. But for the hyperbolic cosine, the domain from minus infinity to infinity and the range from 1 to infinity. So here we have the other hyperbolic functions. For a real number x, the hyperbolic tangent of x is given by, so this one is hyperbolic tangent, x is equal sinh of x divided by cosh of x. And we know that sinh is given by exponential of x minus exponential of minus x divided by 2. So this one will be divided by hyperbolic cos or cosh of x, which is exponential of x plus exponential of minus x divided by 2. So if you divide sinh over cosh, it will be this part, exponential of x minus exponential of minus x, divided by exponential of x plus exponential of minus x, where these two will cancel with these two. So that's why here we have the hyperbolic tangent of x is equal exponential of x minus exponential of minus x divided by exponential of x plus exponential of minus x. Similarly, we have the hyperbolic cotangent of x, where x is not equal to 0. It is given by, so hyperbolic tangent is equal hyperbolic cosine divided by hyperbolic sine. And the hyperbolic cosine is just exponential of x plus exponential of minus x divided by 2. And the hyperbolic sine is exponential of x minus exponential of minus x divided by 2. And 2 from hyperbolic cosine will be cancelled with the 2 from hyperbolic sine and we get this ratio. Here we have where x is not equal to 0, because if x is equal to 0, here we get exponential of 0 minus exponential of 0, which is 1 minus 1, which is 0. And we cannot divide by 0. So that's why here we have x is not equal to 0. Similarly, we have the hyperbolic secant of x. It is given by hyperbolic secant is equal 1 over hyperbolic cosine of x, which is equal 2 over exponential of x plus exponential of minus x. And the hyperbolic cosecant of x is given by 1 over hyperbolic sine, which is equal 2 over exponential of x minus exponential of minus x. Here we have similarly where x is not equal to 0. Because if x is equal to 0, you will have here exponential of 0 minus exponential of 0, which is 1 over 1, 0. So 2 divided by 0, it is not defined. So that's why here we exclude x is equal to 0. So the main thing you need to know that the hyperbolic sine, the hyperbolic cosine, and their form as an exponential function, and the rest will be easy. So hyperbolic tan will be hyperbolic sine over hyperbolic cosine, hyperbolic cot will be hyperbolic cosh over hyperbolic sinh, and the hyperbolic sec will be 1 over hyperbolic cosh, and the hyperbolic cosecant will be 1 over hyperbolic sine. So here we have the graph of hyperbolic tangent, cotangent, secant, and cosecant. So you need to know what is the domain of all these functions and what is the range. For the hyperbolic tan, you see that any value of x can be in this function, so the domain will be from minus infinity to infinity. Where is the range? Just, which is the y-axis, we have the value from minus 1 to 1. So the domain minus infinity to infinity, the range from minus 1 to 1. For the hyperbolic cot, we have the domain can be any value of x except at 0 because this function is not continuous at 0. So the domain will be from minus infinity to 0, then from 0 to infinity. And the range here we have the value for y from 1 to infinity, and here we have from minus 1 to infinity. So the range will be all the values except the interval from minus 1 to 1. For the hyperbolic sec, for the x-axis, you can evaluate any number, so the domain will be from minus infinity to infinity. For the y, you see that it is just in the upper half of the y-axis. So that's mean it is in the upper half of the x-axis. Sorry, that's mean the range will be from 0 to 1 because the highest one will be 1 and the least one is 0. So the domain will be from minus infinity to infinity and the range will be from 0 to 1. For the hyperbolic cosecant, we see that the domain can be any value except at 0 because this function has no value at 0. So it is discontinuous at 0, and we conclude that the domain from minus infinity to 0, then from 0 to infinity. And for the range, it can be any number except, it can be any number, sorry, because it's include all number in the y-axis from negative and also all number from the y-axis in positive. So the range can be any number. So what are the properties of hyperbolic function? Similarly, for the trigonometric function, we have properties that some functions are even, some functions are odd. We have sine square plus cosine square is equal 1, and etc. So for the hyperbolic identities, we have the hyperbolic sine of minus x will be minus hyperbolic sine. So this one told us that the hyperbolic sine is an odd function. Similarly, like the sine, sorry, because we know that sine minus x will be minus sine x. Also, for the hyperbolic cosine, we have hyperbolic cosine minus x, it is equal hyperbolic cosine x. So from that, we conclude that the hyperbolic cosine is an even function. It looks like the cosine function because the cosine function also an even function. For the hyperbolic tan, it's see that the hyperbolic tan of minus x is equal minus hyperbolic tan of x. So we conclude that the hyperbolic tan is an odd function. Also, you need to know that cosh square minus sinh square is equal 1. So for cosine and sine, we have cosine square plus sine is equal 1. But for the hyperbolic, we have the hyperbolic squared of cosine minus the hyperbolic squared of sine will be 1. So you need to distinguish here, we have negative sign. Also, we have 1 minus hyperbolic tan square is equal hyperbolic sec square. And we have hyperbolic cot square of x minus 1 is equal the hyperbolic cosecant square of x. So all these 5, the first 5 you need to know it as your name, but the rest, it will be just an application of the others. This all looks like the identities of the trigonometric function almost, but here for these two we have here a difference. For these three, sorry, we have here some difference. So you need to distinguish between the trigonometric function and the hyperbolic function.